There are black holes scattered throughout the universe, ranging from the remnants of collapsed stars to the supermassive giants that anchor entire galaxies. But among them is one object that stands in a category almost of its own. It is called TON 618, and with an estimated mass of around 66 billion suns, it is one of the most massive black holes ever discovered. It lies more than 10 billion light-years from Earth, meaning the light reaching our telescopes today began its journey long before our solar system even existed. Across that unimaginable distance, TON 618 still shines brightly enough to be detected, not because the black hole itself emits light, but because everything falling toward it releases extraordinary amounts of energy before disappearing forever. Black holes are invisible by nature. Once light crosses the event horizon, the point beyond which escape is impossible, it never returns. This means no telescope has ever photographed a black hole directly in the traditional sense. What astronomers observe instead is the environment surrounding it. Gas, dust, and even entire stars pulled toward TON 618 form an enormous rotating structure known as an accretion disk. As this material spirals inward, particles collide at incredible speeds, heating the gas to millions of degrees. The result is one of the brightest objects in the observable universe, known as a quasar. Quasars are so luminous that they can outshine every star in the galaxy that hosts them. TON 618 powers one of the brightest quasars ever observed. It releases so much energy that from billions of light-years away, it remains visible through some of the world's most powerful telescopes. Ironically, the brightest black holes are often the ones consuming the greatest amount of matter. They are surrounded by light precisely because their gravity is so efficient at pulling material inward. The existence of TON 618 presents astronomers with an enormous challenge. Modern theories explain how black holes grow by swallowing gas, dust, stars, and by merging with other black holes during galaxy collisions. These processes successfully describe many supermassive black holes found throughout the universe. But growing one to 66 billion solar masses is far more difficult. Black holes cannot consume matter indefinitely at maximum speed because the intense radiation produced by infalling gas pushes back against additional material. This natural balance, called the Eddington limit, effectively acts as a speed limit on black hole growth. Yet somehow, TON 618 reached a size that pushes the boundaries of these models. This suggests that the early universe may have been capable of producing conditions far more extreme than astronomers once imagined. Perhaps TON 618 experienced long periods of uninterrupted feeding. Perhaps it grew through repeated mergers between already massive black holes. Or perhaps there are processes occurring in the universe that we have not yet fully understood. Whatever the answer, TON 618 reminds us that nature often finds ways to exceed our expectations. Its sheer scale is difficult to comprehend. Our sun contains more than 99.8% of the mass in the entire solar system, dominating everything around it. Yet compared with TON 618, even the sun becomes almost insignificant. Every planet, moon, asteroid, and comet in our solar system combined would barely contribute to the total mass of this black hole. Numbers of this magnitude stop feeling meaningful because they describe an object that exists far beyond ordinary human experience. Gravity around TON 618 behaves according to the same physical laws that govern every black hole, but on an unimaginable scale. Space itself becomes dramatically curved. Objects orbiting close to the black hole travel at significant fractions of the speed of light, while time slows relative to distant observers, a phenomenon known as gravitational time dilation, predicted by Einstein's theory of general relativity and confirmed through decades of observation. These effects are not unique to TON 618, but its enormous mass allows them to occur over an astonishingly large region of space. Despite everything astronomers have learned, TON 618 remains deeply mysterious. It exists so far away that every observation reveals only a glimpse of its past. We cannot send spacecraft there. We cannot watch its evolution in real time. We can only study the ancient light that has traveled across billions of years to reach us, using it to reconstruct one of the most extreme objects known in the cosmos. TON 618 is frightening, not because it threatens Earth, but because it reveals just how vast and powerful the universe can become. It reminds us that gravity is capable of building structures so enormous that they challenge our understanding of cosmic evolution. Somewhere in the distant universe, matter continues to spiral toward an invisible boundary, releasing incredible amounts of energy before vanishing forever into a place from which nothing can return. The event horizon of Ton 618 is so large that comparing it to Earth, or even the solar system, quickly becomes meaningless. If this black hole replaced the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune would all disappear inside it. In fact, the event horizon would extend well beyond Pluto's orbit. Light itself would require several days simply to travel across the diameter of this invisible boundary. Nothing in our solar system comes close to that scale. Every observation of Ton 618 comes from light that began its journey more than 10 billion years ago. We are not seeing the black hole as it exists today. We are witnessing an ancient chapter of the universe's history. Somewhere in the cosmos, Ton 618 has continued evolving for billions of years beyond the moment we observe. Whether it has grown larger, become quieter, or merged with another giant black hole remains unknown. The universe has already moved on. We are only now catching up. And perhaps the most unsettling part is that TON 618 may not even be the final limit. As telescopes become more powerful and our view of the universe expands, we may one day discover black holes even larger than this, objects that force us to rethink, once again, what nature is capable of creating. If you enjoyed this journey into one of the most extreme objects ever discovered, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss the next exploration into the universe. And if you haven't watched it yet, check out my documentary on Neptune. It explores how the solar system's most distant giant planet hides supersonic winds, disappearing storms, and mysteries we've only begun to understand. It's the perfect companion to today's video and continues our journey through the most extraordinary places in the cosmos.